So tomorrow's test has 12 questions. We're going to put it together with the 8 that you took on Friday. Each one of these questions is worth 5 points. Okay, same thing for the thing that you did on Friday. Everything's 5 points each. So the main thing to remember, back in 5.1, we learned the one-to-one property. So for example, let's say you have 2 to the x power equals 32. Your goal here would be to change the base because we're not using a calculator. So what we're going to try to do is make 32 have the same base as this side. So I could actually change 32 into 2 times 2 is 4, 8, 16, 32. I can change it to 2 to the 5th. Once I get the bases the same, then I just set the exponents equal to each other. I get rid of them. This is the one-to-one property. So this would be one way that you could solve a problem. Now, if it's a question where you couldn't change the base, then, for example, like any of these at the beginning, this would have been a calculator question where you would have had to add ln or turn it into a log and then solve it that way. So if you can change the base, then this is something you can do mentally or without a calculator. Then if you see a question where you have one log, or let's see, a log on either side. Let's see if any of these have that. So like, for example, here on number 12, notice there's an ln here and an ln here. I can apply the one-to-one property, get rid of ln, and then set this equal to each other. And then solve from there. Now, if you have 3, more than one log word, yes. In this case, this is where we have to use our condense. Subtraction means quotient. So I'm going to do log 4x over x minus 3 equals log of 2. Yeah. If you have more than one log or more than one ln, you have to condense. You can't just go through here and say, oh, I'm going to cancel, cancel, cancel. It won't work. So you have to use your properties of condensing. So when it's an addition sign, you would multiply. When it's a subtraction sign, we're going to use the quotient property. So then now I can get rid of the word log because I only have one on the left and one on the right. So then you would cancel now the log, and now I'm going to solve this as a proportion. 4x over x minus 3, 2 over 1. And then I'm going to cross multiply. 2 times x minus 3 equals 4x. Distribute. Get your x's together. Negative 6 equals 2x. Divide by 2. Negative 3 equals x. Now remember, you need to plug this in. Notice it makes both of these negative. So this answer would be no solution. So if your original problem starts out with a log equation, you need to check your answer. If when you plug it in, if it makes any of these negative, then you stop and you throw it away. It's not that you're trying to make sure that the two sides are equal. You're just making sure that what you're taking the log of isn't a negative number or 0. We'll also have to expand. I don't know if there was any expand. I think there was expand on this. Let me go ahead and look for it. So like, for example, this one. We could do this one without a calculator because we only have a log on one side of the equation and not on the right side. So I'm going to turn this into exponential. So BAE, 4 to the x power equals 32. And maybe not. Maybe we can't do this without a calculator. Yeah, we can. So we're going to change 4 into a base 2, 2 squared. We're going to change 32 into 2 to the 5th. Now that the bases are the same, get rid of the 2's. Multiply the power to the power. And now divide by 2. And x equals 5 over 2. You can leave it like that. So this is how you would do it if there's only one log on either the left or the right side. Turn it into exponential. Now, if you have more than one log word, let's just say you have a log on either side. Let me see if there's any questions that look like that. We'll also have questions where you have to expand the expression, like these, and then apply the properties. So mostly for the condense, you're doing that to solve the equation. But the expand, you're just going to apply the properties. The product property, the power property, and the quotient property. You'll also have to graph. So, for example, don't forget that, for example, on this, something like this, number 38, when this base of this exponent is the base of the log, and you're not even on the board. So hold on. And whenever the base of the exponent is the same as the base of the log, that'll cancel out. And then this goes right to the answer here. Same thing if it were like a log base for, let's say it was let's say log base. We could even say, I'll do a 9 and a 9. And then let's say this had and x equals 5 or something. This will cancel. And again, remember, whenever the base of the log and the base of what you're taking, that'll also cancel. So look for little tricks like that. Be able to apply your properties. If you have something like with an ln(e), remember if something's being multiplied to that, you can turn that into a 1. So look for the properties and apply those to make the problems a little bit simpler. Things like that. So again, 12 questions tomorrow. 9 of them are finding x, 1 expand, and then 2 graphing. So on the graphing, don't go crazy with points. Just give me 3. And again, be able to identify the asymptotes, the intercepts, domain, and range. Anybody have any? Nothing here, so let me, which I think is on here. You're going to have to graph an exponential equation, and you're also going to have to graph a log equation. Remember, for this, you're just going to do a little chart. That's going to be your easiest way, and then I would apply the shifts. So, for example, on this one, I'm going to go ahead and on the test, you're going to have to identify, just like in the homework, the WebAssign, identify asymptotes, identify intercepts, x or y. Remember, you just plug in the zeros, and then also give domain and range. All right, everybody good? So just like I did in the notes yesterday, but for both of these. So like for the exponential, all I'm going to do is do 3 points. You don't have to go crazy and do a whole bunch of points. Now, you can either choose, if it's something this simple, just plug in your -1, your 0, and your 1 for your x's. This one didn't have any shifts, but if it's got shifts, plug it into the base and then apply the shift. Like if it had a -1 here, I would just plug it into this if you want, and then apply the shifts to it. But like, for example, on this one, if you plug in 1/3 and then raise it to the -1 power, think reciprocal, this flips and it becomes +3. Remember, anything to the 0 power is 1, and then 1/3 to the first is just 1/3. So we're going to go ahead and graph these. So -1, +3, the 0, 1, and then the 1, and then the 1/3. Notice I've got an asymptote here. So my horizontal asymptote here is going to be, and it's an equation. If you just put a number or something, you're going to get it wrong. So this has a horizontal asymptote of y equals 0. And then if I connect my points, skims along. The domain here is all real numbers, because this is going to just keep on going. Notice the arrows on the ends. However, the range, all the y values are above this asymptote. So my range goes from 0 to infinity. It's only positives. And then the y-intercept is this order pair right here. If you see that you have an order pair, and on the exponentials, it's easy to see because if you plug in 0, you can automatically find it. Now remember, if it gets shifted, that y-intercept will shift as well. So again, be able to give me at least 3 points on your graph by doing your little chart, and then tell me the asymptote. If it's horizontal, it'll specify in the problem. Here, when it's exponential, it'll be horizontal. When it's log, it'll be vertical. Be able to give me domain range, and then either an x or a y-intercept. So just remember, when you're finding an x-intercept, you're setting y equal to 0. And when you want a y-intercept, you're setting x equal to 0. And then solving the problem. And that'll give you the order pair. Remember, the intercepts are always written as order pairs. Questions about anything? And then you're also going to have to graph. Here's some more exponentials that you can practice with. Again, you have this on this review. Solutions. And then you're also going to have to graph a log. For example, on this one, I would do just the y equals log base 3 of x. And then I would apply the shift. When it's in the parentheses, it's backwards of what you would think. So this is actually 2 to the right. And then from there, I would do my little t-chart. Remember, when you're doing the log graph, you're plugging in numbers for y. It's easier. So x and y, plug in -1, 0, and 1 here. And then if you go ahead and plug this in, turn this into exponential. I would move the y equals to the back. So BAE. So 3 to the y power equals x. So then what I would do here is plug in 3 to the -1. That's going to be 1/3. 3 to the 0. That's going to be a 1. 3 to the first. It's going to be a 3. So then the order pairs that you can graph are right here now. Yes. So we would come over here and graph 1/3, -1, 1, 0, and then 3, 1. Now, remember, we got to shift these. If you want to connect them, that's up to you. But I'm going to shift them before I connect them. I'm going to shift them all 2 units to the right. So this will become here, here, and then the 1/3, 1, 2, oops. And then now we can graph it. Notice the original horizontal asymptote for the blue one was x equals 0. When you shift your graph 2 units, your asymptote shifts as well. So my vertical asymptote here is x equals 2. That's the vertical. The domain here is only from the 2 to infinity. It's where the asymptote starts. So the domain, 2 to the infinity. The range on the logs is always all real numbers. And then the x-intercept, we can clearly see it from the graph. We can see that it's the order pair 3, 0. Now, if you couldn't see it, if it were a fraction, then you should do the math with the original. Everybody with me on that? Because like the original, you could do this. F of x, fancy way of saying y equals. I'm going to move the y equals to the back so I can do my Bay trick. So now BAE, so it's 3y equals x minus 2. Remember, when we want to find an intercept, we're going to plug in a 0. And this becomes 1. Add the 2. And you can now see that your x-intercept is the order pair 3, 0. So again, be able to graph a log and an exponential. 12 questions tomorrow. Be able to solve these log equations for x without a calculator. Also be able to expand. So 2 graphing, 1 expand, the rest are all solve. Again, the review with the solution file is up, and these answers down here at the bottom.